Hello, and welcome to the ParAqua-COST, the science podcast that shines a light on the newest and most interesting research being conducted in the fields of aquatic and marine ecology. My name is Joe Money, I'm a PhD student and the host of this podcast. Today, I'm joined by Professor Gabriel Acien, who's a professor of chemical engineering at the University of Almería in the south of Spain. We'll be discussing his research into industrial applications for algal aquaculture and how research into fungal parasitism can help prevent setbacks in this growing area of research. Gabriel, how are you doing?
Fine. How are you?
Yeah, not too bad. Just enjoying the last of the summer sun here in Poznan. How are things in Spain?
Fantastic. The weather is perfect, and then we are producing a lot of microalgae currently.
Perfect. Nice weather is nice for us, and it's also nice for our research, I guess.
Yes.
Well, I'll try not to keep you too long on the podcast so you can go out and enjoy the nice weather.
Okay, thanks for your invitation to participate in this podcast.
No problem. It's a real pleasure to have you on. So could you just give us a quick summary of your background, education, and research history, just so we can get to know you a little better?
Yes, of course. I am professor of the Chemical Engineering Department of the University of Almería, but I perform my bachelor studies and master studies at the University of Granada, also in Spain. But once I finalized these studies, I decided to move to the University of Almería because in Almería, a young group of researchers start to perform research about algae production, especially microalgae, for largely different applications, health, and foods, and aquaculture, etc. This is the motivation to start to work in this topic.
Nice. And did you grow up in Granada or in this area of Spain?
No, I was born in Almería, but I complete my studies in Granada.
Ah, I see. Okay. So you've come back.
Yes, I come back to the University of Almería, especially to work on this field in microalgae biotechnology.
That's really good that you get to work and live in your hometown. That must be quite rewarding. And also, I have to say there was a recent ParAqua meetup, wasn't there? There was a workshop in Almería, and unfortunately I couldn't go, but it looked amazing.
Yes, it was a very nice workshop because we were able to join 30 researchers from Europe, especially young researchers, and then we enjoyed 3 days sharing and discussing about this field.
Yeah, and I was able to join online, but unfortunately, I think it's a bit better in person often these workshops, isn't it? But I still really enjoyed the lectures and the information. So I'm guessing that algal aquaculture is a term that most of our listeners probably aren't familiar with. Could you describe this area of research and why it's becoming increasingly important to many vital industries?
Yes, I can summarize that, or I can introduce the audience that most of the people know the algae that grow in the oceans. However, this amount of algae growing naturally in the ocean is not enough if we want to produce foods or feeds, or including nutraceutical, etc. And then the industry is looking for technologies to be able to produce this algae. Some companies are focusing the production of this algae in the oceans, but it can be in conflict with the use of the oceans, the contamination of the ocean, etc. And this is the reason because other researchers, other industries are focusing the production in land. And then we are working in this topic, how we can produce algae similar to other crops in land, but minimizing the use of resources. I mean, not using fertilizer, not using fresh water, etc. And then to be able to produce these algal products as alternative to the conventional crops.
Yeah. And I think I'm right in saying that the carbon dioxide absorbed by the oceans and the algal population in the oceans vastly outweighs the carbon dioxide absorbed by even the largest forests. So this is definitely an area that we can expand on if we're really serious about tackling climate change. Isn't that right?
Yes, it's right. I mean, as you say, the oceans are fixing enormous amounts of CO2 naturally because macroalgae and microalgae growing there are fixing. But also, if we are able to perform this process in land, we will be able to increase this capacity, including some companies are now interested to produce this type of algae for the production of bioplastics. I mean, producing other materials alternative to fossil-based materials.
Yeah, yeah, it seems like a really interesting, innovative area of research. And that kind of brings me on to my next question, really, which is, Gabriel, you've given your extensive research career, I think you've contributed to over 250 published papers in numerous scientific fields. What was it exactly that attracted you to this area of research in particular?
I decided to focus in this area, especially for the high potential of these technologies. I want to remark that the algal technology is quite new, more or less 30, 50 years. And the potential of this technology to contribute to the challenge of the humanity, of the mankind, is tremendous, because we can, as I say, produce similar material that conventional crops, but much more efficiently and much more sustainable. And this is a large opportunity to produce food, feeds, material, but including biofuels. Then the European Commission already mentioned that this is an important field to push, because it's important the potential contribution in the next decades about these topics.
Yep, I definitely think there's so much more research that can be done in this area, and I think that's a great reason to get into it. It's always interesting to sort of be a pioneer in a new area of research, and it definitely seems like you're definitely one of these pioneers.
Yes, especially because not only research, but also entrepreneurs and spin-offs and small companies they currently start production facilities, and the amount of production facilities, the amount of people involved in the industrial sector is growing very fast.
Yep. Industry and research, you've got it all there, really, don't you? Yeah, and speaking of industry, actually, is there any particular industry that you think will be revolutionized by the processes involved in algal aquaculture?
Yes, I think that the contribution of algae for the production of food is already established. It's only a matter of increase the production capacity, because all the processes and technologies are well developed. But now we are more or less focusing low-value application as the production of biofertilizers, the production of biomaterials. I think that this is an opportunity for the industry to replace fossil-based materials by this type of organic materials. And probably in not a long term, we will be able also to produce biofuels and energy carriers different than the ones based on fossil fuels. And it could be also a very important opportunity.
Yeah, that sounds really good. I think one of the things that the listeners might want to know about is actually how physically these algal products and these algal foods are grown. Is there a system that you use? Is it in septic tanks? Is it on these sort of growth media platforms? Could you describe it just quickly so everyone has an idea in their head of what exactly these algal production plants look like?
Okay, it's quite similar to the conventional crops. I mean that the plants, they need water, fertilizer, and they are able to capture CO2 from the air to grow. In the case of algae, algae don't have roots or structures. That means that they grow naturally floating in the water. That means that we need to install systems on which the water is recirculated. In this water, we put the seed of the microalgae. We put a small amount of microalgae, and microalgae grow very fast. Day by day, they duplicate. We need to provide also some nutrients, some a certain amount of CO2, etc. But this is also a very interesting topic, because if in these water bodies, in these water systems, we provide not fertilizer, but including manure or other effluents containing nutrients, or including flue gases containing CO2, microalgae are able to capture all these nutrients and to transform these nutrients that can be potentially contaminants into valuable biomass for different applications. Then the technology is quite simple, but of course you need to develop the right engineering about how to manage the system.
Yeah, so you're taking effluent and waste products basically, and using the nutrients that are locked up in those toxic compounds that can be broken down, and those are feeding the algae. Is that broadly correct?
Yes, it's correct. I only want to differentiate for the audience that algae produced for human applications are never produced using this type of effluents. They are produced only using clean water, pure CO2, and pure fertilizer, like the typical crops. But algae have also this other potential application, then to be able to reuse effluents to produce biomass, not for human application, but for biofertilizer, for biofuels, or whatever other applications not related with human consumption.
Yeah, I see. Because I guess there are a lot higher regulations for consumptive algals, I guess, than ones that are used for sort of industrial processes, like you mentioned. That makes a lot of sense. And
Yes,
thank you for the reassurance. Yeah.
Yes, the industry also have safety criteria. I mean, to prevent whatever risk for human population, then not residuals, not effluents with potential contaminants can be used to produce human-related products.
I see what you're saying. So as you've related the growth of macro and microalgae to crops, with every crop, there is always pests. There's always things that you don't want that are eating your food or contaminating your food. And that's a tale as old as time. But one of the reasons you've become a key member and working group leader in the ParAqua network is because of the importance of preventing and regulating fungal parasite outbreaks in these algal aquacultures. So what mechanisms are in place to prevent these outbreaks from occurring?
This is a very important question because at this time we don't have a lot of tools to manage this type of contaminants. I already explained that we are developing this technology, it's recent technology. Then only when we are starting large facilities, more or less 10-hectare facilities or whatever, we are identifying this type of problems, this type of disease in the cultures. Never, we don't have a previous experience about that. Then the actual tools or the tools that the industry is applying is, in one side, to prevent contamination. I mean, to only use clean water, clean materials, etc., avoiding the entrance of these fungi into the system. But for large-scale production, especially using effluents and whatever, it is not possible to treat the water entering into the process. Then we are developing some biological tools. I mean, bacteria that attack to the fungi or some modification of the cultural conditions to prevent that the fungi have good cultural conditions to grow, etc. But I repeat again, we are starting this type of research. This is the importance of ParAqua project, because in the ParAqua project, experts from different fields, ecology, microbiology, etc., all together, we are collaborating to identify the natural mechanisms regulating the growth of these fungi in the nature. And then we are trying to mimic these natural mechanisms into the large production system.
Yeah, and one of the working groups that I've been particularly a part of in this ParAqua network is the identification sort of stage of understanding fungal parasites. I guess that's also a massive part of, once you've got a contaminated algal culture, you really need to identify what it is that's contaminating it.
Yes, this is very, very interesting question, because the first step to fight versus a fungi or whatever pathogen is to know the pathogen that we have in the system. Then, especially people from molecular biology, they already have methods based on this type of genomic analysis, and they already identify which are the most the prevalent fungi in the culture. The good news is that only few fungi are present in the microalgae cultures. Then we don't need to fight with all the fungi that there are in the nature, only some of them. And also it's really funny that we identify that some fungi are associated with some specific strain, microalgae strain. Then it's only it's a question of symbiosis or something like that, and or parasites. And then we need to fight for whatever specific algae with a strict or very reduced number of fungi attacking this, fighting this strain. Then we are now learning this type of natural system in order to be able to develop tools for the prevention of these problems.
Yeah, I think as you mentioned before, this area of research and industry really highlights how a multi-subject approach is really important in this because, as you mentioned, ParAqua enables us to collaborate with chemical engineers such as yourself, ecologists, microbiologists, mycologists. Having a broad range of tools at your disposal is, I'm sure, vital in this situation.
Yeah, this is very important. I repeat again that we are more or less in the infancy of this type of technologies. The same that crops or conventional agriculture, they fight versus pathogens using chemical tools, biological tools, etc. A lot of different expertise collaborate in the development of agriculture. And this is very important. How large is the production of foods by agriculture? Then more or less we are in the same range or the same scenario concerning microalgae. We need the collaboration of different expertise in order to accelerate the growth of this sector.
Yeah, completely. So, Gabriel, I think one of the things that might be people's perception of this sort of algal aquaculture is that it's a sort of a high technology, modified, supplement-based industry that isn't quite in keeping with their ideas of traditional farming. So is there anything that you can say to sort of reassure people or clarify to the general public how exactly this industry isn't all of those things that I've just said?
Yes, of course. I want to remark that algae producers, especially in Europe, are using quite traditional methods. Then they are not using pesticide, chemicals, or whatever. It's a very simple technology on which in the reactors, in the water system, we are only using natural compounds, especially some nitrogen and phosphorus sources, and we produce the biomass, dry biomass that is commercialized. Then I repeat again that is a very safe material, very well accepted by the consumers, and accomplishing all the regulations in Europe, including contributing to the development of rural areas, which is also very important for Europe.
Yeah, so I think you're summing it up really well there. And I think what's worth reminding the listeners and consumers in general is that the diversity provided by these sort of algal products when they're consumed by humans is that they are really full of nutrients and healthy materials, and they don't have these sort of boogeyman side effects that genetically modified crops are perceived to have.
Yes, we don't produce genetically modified organisms. Only natural strains are produced, like spirulina, chlorella, hematococcus, and all this strain has been demonstrated that in addition to the nutritional value, I mean proteins, content, etc., they also provide health improvement properties. I mean antioxidant properties, anti-diabetes, etc. Then all the studies already performed about this topic demonstrate that the consumption of algae is very positive for the consumers. The question is that we need to enlarge the production capacity and also to facilitate the access of the consumer to this type of materials.
Yeah, it seems like the efficiency and the marketing are the things that almost need to be focused on because the science is basically there. So is there any upcoming research projects or collaborations that you're excited to work on that you want to tell us about?
Yes, we are recently starting some projects about bioenergy, producing different energy carriers based on algae. But I want to remark the REAL project. The REAL project is an EU project that started more or less 1 year ago, and is focused in the production of algae connected to the drain water from agriculture. Because most of the people perhaps are conscious that agriculture use a lot of nitrogen, and part of this nitrogen go to the water bodies, and it's supposed a contaminant compound. Then we are developing a system collecting the drain water, producing the algae with this drain water in order to recirculate clean water to the greenhouses, at the same time that we are producing algae biomass to be used for feed applications and for agriculture application as biostimulants or aquafeed, etc. These are very important projects because we can offer to the farmers an additional return from this type of production. Then they will be producing tomatoes, but at the same time, they are producing certain amount of algae as a byproduct, and all the process will be much more sustainable.
That sounds really good. And especially as an aquatic ecologist myself, the idea of reducing the nitrogen input into freshwater systems sounds great, because that is one of the big problems that we have to deal with when we're dealing with freshwater pollution and stuff like that. So that sounds like a really interesting project, and I hope to read about it more, definitely. So final question. One of the potential uses of algal aquaculture is the production of edible algal supplements. Isn't that right? So we've just been talking about the production of food, but on the recent ParAqua workshop in Almeria, I saw some edible algal products that were handed out to the participants. And as amazing as the science sounds, they didn't look that tasty. So what do you think of the edible algal products, and what dishes do you think that maybe we could work them into?
Yes. We need to produce algae for different applications. For food application, it's true that sometimes the smell or the taste or whatever is not well appreciated. It depends on the consumer. Some consumers like it, but other consumers don't like it too much, this type of products. Anyway, the food industry normally fight with this type of problems. I mean, sometimes they extract or they remove from the biomass the inadequate compounds, providing this typical smell or tasty, or we can include the algae biomass in different matrices. Then, according with the matrix, we can cover more or less these problems. It's a question of food technology. I mean, how we use the biomass for different food or final foods. But anyway, this is a technical problem that is more or less solved according with the final application.
Yeah, and like I said, all that happened was that I saw the food and it just looked a little strange, but I never tasted it. So I'd love to give it a try. Maybe next time there's a workshop in Almeria, I'll get to try some, and I'm sure it'll be very nice. It looks sort of like it would taste like spinach. I don't quite know if that's true. Yeah.
Yes. Very good comparison, like a spinach.
Okay, that's fine. So not good for kids, but maybe good for adults. Yeah.
Yes.
Okay, well, Gabriel, it's been a real pleasure having you on. Thank you so much for the chat, and I found it really enlightening. Learned a lot myself, and I hope the listeners have too. So thanks.
Thank you to you.
The ParAqua podcast was funded by COST, the European Cooperation in Science and Technology, and is a product of the ParAqua Action Group. If you are interested in joining an action group or just want to know more, please go to www.paraqua-cost.eu or follow the link in the episode description. The podcast is produced by myself and Serena Rasconi, and the Science Communication Coordinator is Anna Gavrilovich. Once again, thanks for listening, and see you next time on the ParAqua podcast.